All right, hello, welcome back. So in this video, I'm going to cover something called the PMT function. And PMT function pertains to annuities. We've looked at annuities, how to solve for the present value of an annuity and the future value of an annuity. In this case, we're actually going to solve for the payment of an annuity, which oftentimes does come up, especially in a lot of retirement problems and saving problems. But basically, we're going to be given everything but the payment, and we have to solve for the payment. So let's start off with an example. Number one, a 60-year-old retiree currently has $344,612.37 in savings. She expects to live another 38 years, and she can earn an annual interest rate of 4.83%. What is the maximum amount of money that she can withdraw each year for the next 37 years if she begins her first withdrawal in one period in 1 year? So basically, in this case, we're assuming that she's not going to make a withdrawal this year, or she's already made her withdrawal this year, and so this 37 will be for her last year, I guess, this 37th year. So we can see that this is basically an ordinary annuity, okay? And we need to see how much she can withdraw each year, right? And basically in this last year, that's going to be her last. She's not going to have any more money after that. So let's go up to 1 here, and we'll do equal sign, and we're going to use PMT and open parentheses. So this is the PMT function, and so again, rate, we just put in the interest rate, which is 4.83%, so we got to put that in decimal form, so that's 0.04843, then comma, number of periods, it's 37, right? And then the present value, that's what we need. Now, that $344,612.37, it's not a cash outflow, right? But it is negative in the sense that she's not accessing it. These payments, when they come to her, they're going to be a cash inflow to her, or at least they're going to come to her. So those will be positive. So we want a positive number here. So we need to put this as a negative, and we do negative 344. Now remember, no comma for thousands, so 612, and then 0.37. Okay, and then comma, and she's not going to have anything left right in the last year, so the future value is 0. And because this is an ordinary annuity, we do comma 0. All right, let me close that parentheses, and we see that she'll be able to withdraw, right, $20,200 each year, $20,200.32 each year for the next 37 years. Okay, all right, so let's move on to the next problem. All right, a 30-year-old expects to retire when he is 70. He hopes to have $710,000 at the time of his retirement. He can earn an annual interest rate of 4.592%. If he makes his first annual savings deposit today, what annual payment must he make each year to reach his retirement goal? Okay, as we can see here, he's making his first savings deposit today. So that indicates this is an annuity due, and you can see from the timeline, the first payment starts at time 0, not at time 1. Okay, and so we need to find, how much he'll have. Actually, I said 70. I meant to say that this is actually a 40-year period. There is a mistake here. This should be 40, and this should be 39. I do apologize for that. So basically it's going to be in 40 years, right? So our period is 40. So let's go to our Excel sheet. We'll do equal sign PMT open parentheses, put the interest rate in. It's 0.04592 comma, number of periods. This is where, sorry about this mistake, but yeah, it's 40 period. So there's no present value, even though he's making a payment today. But that's what we need to find. So we'll put 0 for the present value. And, this future value of 710, that's what he's going to have. That's going to be kind of a cash inflow to him when he turns 70. You can see where I got confused. This is in 40 years, but it's not 70. And so that's going to be just 710 and then 000 and comma. And because this is an annuity due, we need to put a 1 and then press enter. And so basically, in order to reach this goal, he's going to have to deposit $6,203.66. And of course, that's negative because he's going to be paying that into the savings account. So it's kind of an outflow from him into wherever the savings account is. All right, moving on. How about, all right, a 70-year-old retiree has $492,094.55 in savings for retirement. The retiree can earn an annual interest rate of 2.94% if she makes her first withdrawal today. What is the maximum amount of money that she can withdraw each year? So you notice this is kind of like a similar problem we had before, except we're solving for the payment, not the present value of those payments. Okay. So, once again, we'll do equal sign PMT, open parentheses. The rate is 0.0294. Number of periods is 30, right? But she's going to withdraw her first payment today. So that's an annuity due, right? The present value, again, that $492,094.55, that's not really available for her today. So the payment's going to have to be a positive amount. So that this present value needs to go in as negative. So that's 492,094.55, comma. There's no future value because she's expecting not to have anything else when she, well, passes away. So 0. And then type, because this is an annuity due, we need to put a 1, and then comma. Let me see that she'll be able to withdraw $24,200.48. Now, in the previous example we looked at, in the present value case, in the last video we saw that she was only going to withdraw $14,000, right? But because her savings is actually much higher, she's actually able to withdraw about $10,000 more. Okay. Lastly, let's look at the last one. So, a 22-year-old hopes to have $70,000 for a home down payment in 13 years. She can earn an annual interest rate of 5.127%. If she makes her first savings payment in 1 year from today, that indicates this is an ordinary annuity, what annual payment must she make each year in order to reach her goal? Okay, so once again, let's go to 4 now. Now this is going to be a cash outflow, right? Because it's a payment into a savings account, so we should expect to get a negative number, or at least a red number. So equal sign PMT, rate is 0.05127, comma. Number of periods is going to be 13. The present value, there's no present value because there's no payment made today, and there's nothing expended or brought in today, so that's 0. Future value is going to be 70,000. 1, 2, 3. It gets, when you have a bunch of different, remember, don't put the comma, but you know you might have to count the zeros sometimes. And then comma, because it's an ordinary annuity, it's going to be 0. And basically, the 22-year-old is going to have to make annual payments of $3,920.09 in order to reach this $70,000 goal in 13 years. Okay? All right, so that'll do it for that. In the next video, I'm going to talk about the NPER function in PER, right? And that's for, and I'll relate that to the rule of 72 like we saw in previous videos. All right, so that'll do it.